Hi everyone, I am Chosun Zinda, who is chemical engineering student from T3 class. In this video, I will walk through how I solved the two problems of my EMaths project, one involving relative motion and ring and another involving circular motion on a Ferris wheel. I will explain how I thought about each situation, choose the right concepts and formulas, and walk through the math step by step. The first question involves a student in a car accelerating away from a traffic light during a tennis throw. The student observed that the ring streaks on the side window change angle from 45 degrees to 60 degrees with vertical over 2 seconds. We are told that the car's acceleration is 1.3 meters per second square and the ring is falling vertically at a constant speed. So what we have to estimate is the vertical speed of the ring. The key insight here is that the observed angle of the ring streaks depends on the relative motion between the falling ring vertically and the car moving horizontally. Since the ring is falling vertically and the car is accelerating horizontally, the angle that the ring appears to make changes over time. At each moment, the student sees the ring at an angle based on the ratio of the car's horizontal velocity to the ring's vertical velocity. So the angle the ring streak makes with the vertical is determined by tangent alpha is equal to velocity of the car Vc divided by velocity of the ring Vr. In there, what the alpha is mean the angle of the ring streak. By swapping the formula, Vc is equal to tangent alpha into Vr. At the initial time, 1t is equal to 0. The angle of the ring streak is 45 degrees. So by substituting this to the equation, we can get the velocity of the car is equal to velocity of the ring at the time t equal to 0. After 2 seconds, the angle of the ring streak changes to 60 degrees. So the velocity of the car becomes to root 3 velocity of the ring after 2 seconds. We already know the acceleration of the car, and to find the velocity of the ring, we can use the formula acceleration equal to final speed minus initial speed divided by time, where final speed is the velocity of the car at the 2 seconds and initial speed is the velocity of the car at the t equal to 0. So by using all these value and substitute to the formula, we can get the velocity of the ring or the speed of the ring, which is equal to 3.55 meters per second. Moving on to the next question, we are dealing with the circular motion on a Ferris wheel at a theme park. The Ferris wheel rotates passengers in a vertical circle of radius 5 meters at a constant angular velocity of 3.14 radians per second. We are asked to make the time for one revolution, the linear speed of the passenger, the centripetal acceleration of each passenger, and force which the cubicle exert on Mr. X when he was at the bottom of the Ferris wheel. So for the first part, to find the time taken, it takes to complete one full circle. So we can use the relation between angular velocity and the time, where angular velocity is equal to theta by t. To solve this one, we need to know theta. So theta can be used as one revolution for the Ferris wheel, which is equal to 360 degrees or 2 pi. In this question, we can use pi because we can use 2 pi because it is the pi value is given in the question. So by substituting these values to the formula, we can get the time taken, which is equal to 2 seconds for one revolution of the wheel. Moving on to the second part, we need to find the linear speed of each passenger. So what is the linear speed? Linear speed is how fast the passenger is moving along the circular path. To find this, we can use the formula of angular velocity equal to v by r. By substituting the values to the formula, we can get the linear speed of each linear speed of the passenger, which is equal to 50.7 meters per second. For the third part, we need to find the centripetal acceleration. In this question, the passenger is constantly changing direction, which means there is an acceleration towards the center of the circle. This is called the centripetal acceleration. To find this, the formula we have to use is A equal to R omega square. By substituting the values to the formula, where R is the radius of the circle and omega is the angular velocity of the wheel, so we can find the centripetal acceleration of the passenger. So A equal to 49.298 meters per second square. For the last part, in a circular motion, something must constantly pull the object towards the center of the circle to keep it moving in a curved path. This requires a work force is called the centripetal force. In this question, centripetal force is required. To solve the force which the tubercle exert on Mr. X when he was at the bottom of the Ferris wheel, we need to find two forces, which is called the centripetal force and gravitational force. At the bottom, the normal force must support both gravitational force, which is downward, and the centripetal force, which is upward to the center of the wheel. So it becomes like this. F total is equal to F plus W, where F is equal to centripetal force and W is equal to gravitational force due to weight. To solve this, we need to know G value and A value. For G value, we have to use 9.8 meter per second square because of the gravitational force. And for the A, we can use the centripetal acceleration from part 3. So unless we substitute all the value to the formula respectively, and the force we have to find when the duplicate exerted on Mr. X when he was at the bottom of the Ferris wheel is 95909.8 Newton. That's the end of my video, and thank you for watching it all the way to the end. I hope you will be satisfied with my step-by-step explanations for each question, and you will be catch the main concept for each question. Thank you.